Hello, and here we are with examples 3 and 4 from the exam review. I'm going to do both of these in one video since they touch on some similar trigonometry skills. So starting off with example number 3, we need to find the exact value of the secant of 7 pi over 6, subtract the tangent of 3 pi over 4. To do this question, we're going to need to use special angles to find exact values of these trig ratios. And we're also going to need to use cast rule to make sure we're putting the relative acute angles into the right quadrant for these ratios. So, secant of 7 pi over 6. Now, we can't actually find directly the secant, but we do need to use our quotient identity to recognize that secant is 1 over cos. So I'm just going to rewrite this expression as 1 over the cos of 7 pi over 6. Subtract tan of 3 pi over 4. And we need to find these individually. Now, neither 7 pi over 6 nor 3 pi over 4 are special angles themselves. However, they are multiples of special angles. So we can find the relative acute angle that they relate to, find the ratio from the special triangle for the relative acute angle, and then put it into the correct quadrant that it exists in, making sure that it's positive or negative in that quadrant. So the relative acute angle of 7 pi over 6, remember that the relative acute angle always comes from the denominator. So the relative acute angle for 7 pi over 6 is pi over 6. And the RAA for 3 pi over 4 is pi over 4. Now, we do need to make sure we're putting these in the right quadrant. So let's first look at this 7 pi over 6. 7 pi over 6 is in quadrant number 3. Seven pi over 6, and the relative acute angle will be pi over 6 coming from the x-axis. And here, this is cos. So here we do need to remember that cos in this quadrant is going to be negative. So if we're taking cos of pi over 6, then 7 pi over 6 will be the negative of that. And then our second angle is the tan of 3 pi over 4. So 3 pi over 4 is in quadrant 2. And this is tan, and in this quadrant, tan is negative. So we'll need to keep that in mind as we go through. So let's do the cos one first. Now what I'm going to do is, since we're finding the cos of, or we're finding really the secant, or 1 over cos, I'm going to find the cos of pi over 6, and then I'm going to flip it upside down at the end. So we're finding the cosine of pi over 6. And we've got to look at our special triangle and see for pi over 6 what are the side lengths, the adjacent over the hypotenuse, which in this case is going to be root 3 over 2. And now we need to recognize that this is pi over 6. However, that's a relative acute angle of 7 pi over 6, which in this case is negative in quadrant 3. So cos of 7 pi over 6 is negative root 3 over 2. And then what we need to consider is actually we needed to find the secant of 7 pi over 6, which is the reciprocal, so we need to flip it upside down. So there's negative 2 over root 3. Next is tan. So we're finding the RAA here was pi over 4. So the tan of pi over 4, we're looking at the adjacent over, the opposite over the adjacent of pi over 4, which is 1 over 1. And remembering again that in this case, tan is negative in this quadrant. So we make it negative 1. Put it all together. We've got the secant of 7 pi over 6. Subtract. We need to do this last step at the end and subtract the tangent from the secant. So the secant was negative 2 over root 3. Subtracting negative 1. And in order to subtract -1 from -2 over root 3, we do need to get common denominators. So we can put -1 is really over 1. And to make that the common denominator with root 3, we're going to go -2 over root 3, subtract -root 3 over 3, because that's equivalent to -1. And now, pardon me, -3 over root 3. And now we can do a subtraction, so we've got -2, pardon me, let's put that on top. We've got -2 subtracting root 3, so we're adding root 3 over a common denominator of root 3. And that's our final answer, -2 plus root 3 over 3. Now we have a trig identity we need to prove here in example number 4. So to prove a trig identity, we're going to split up our identity into left side and right side, and then work and simplify with them using our trig by applying trig identities to make the left side and the right side equal. So our left side here is cotangent x plus tan x, and the right side is secant x times multiplied by cosecant x. And let's work with the right side first, because there's not too much we can do with the right side, but I'm going to apply and by the way, there is multiple ways you can solve this. I'm just going to go through one way. You might work with the different sides in different orders and get them equivalent at different points, depending on how you start and where you go. So if you do something a little bit different, that's totally fine, as long as you make your proof. Okay, so I'm going to apply the reciprocal identities first and just turn everything into sine and cos, because that's what I like to do. So secant is equivalent to 1 over cos, and cosecant is equivalent to 1 over sine x. And I'm going to leave that there for now. I don't want to go multiplying those, it might get a little messy. So we'll leave that there for now, and then we'll start working with the left side and see where we get from there. So cotangent x and tan x, I can apply my quotient identity to these, recognizing that tan x is equal to sine over cos. And the cotangent x is the reciprocal, so the quotient rule and the reciprocal rule, identity applied at once to cotangent x gets us cos x over sine x. And we're adding these together. Now, we can't directly add these together because sine x and cos x are not common denominator. So in order to do that, I want to make sine x and cos x, these two fractions, have the same denominator. So what I'm going to do I'm going to multiply the cos x over sine x by 1, but not just 1, I'm going to multiply it by cos x over cos x. To make my denominator sine x cos x, and then I'm adding sine x over cos x. And now to make the denominator the same on this side, I'm going to multiply by sine x over sine x. So I'm not changing anything because I'm just multiplying by 1, but this is a little trick we can use. In order to make our denominators the same. So this is going to give us cos squared x I'm making a mess. Cos squared x over sine x cos x plus sine squared x over cos x, or sine x cos x again. Now I've got the same denominator, so I can add these together. And what we can recognize here is our reciprocal identity. Sorry, not reciprocal, as the Pythagorean identity. Because we've got cos squared x plus sine squared x all over sine x cos x. Now we know that cosecant squared x, cos squared x plus sine squared x is equal to 1 according to the Pythagorean identity. So this is really equivalent to 1 over sine x cos x. And now to make this really obvious that this is the same as my left side, as my right side, we're actually equivalent at this point, but we'll just break up the fraction. So this is 1 over sine x multiplied by 1 over cos x. These are equivalent. My left side and my right side are the same. And we're done.